Hello, my name is Abel Lovaco and study agrogenomic science. In this space, I'm going to present the research work that I carried out during the last year of my degree. The name of this work is InDel-Mex, a pipeline for detection of long deletion in ORFS 7A, 7B, and A in SARS-CoV-2 genomes. SARS-CoV-2 is a coronavirus that has a 30 kilobase genome, which code for the different structure of the virus. Through its spread in the world, it has generated mutation in other parts of the genome. These mutations are highly relevant because some of them could confer some advantage to viruses. As can be seen in this graph, the frequency of the lineages that have circulated around the world has brought with new variants and made others obsolete. In Mexico, INER, which is part of the Mexican Genomics Surveillance Consortium, detect an interesting mutation. This mutation is a possible 411 nucleotide deletion in SARS-CoV-2 genomes. Previously, deletion of this type had been detected in the SARS-CoV-2 genomes in the USA. This deletion appears to be linked to the B.1.43 lineages. These lineages began to have relevance in Mexico, so we were interested in knowing the frequency of these deletions in Mexico. To find out if deletion existed in samples from Mexico, I was decided to test INDELseek. INDELseek is a software that detects log deletion, but was unable to detect 411 nucleotide deletion present in SARS-CoV-2 genomes. The analyses were run with the pre-configured parameters. To corroborate this deletion, the PCR technique was used with specific primers to amplify the region of ORFS7B and A. Subsequently, these amplicos were sequenced using the nanopore and Sanger technology. In order to validate the other samples, a pipeline was carried out to detect these deletions. InDel-Mex was programmed to parse BAM files. This pipeline looks for reads that falter in the regions of the deletion. That is, reads that align both at the beginning and the end of the deletion. Subsequently, a second method counts the number of intersecting nucleotides in deletion regions. If deletion is real, the size of the intersection should be 0. Finally, InDel-Mex showed whether or not there is a deletion, as well as if there are intersecting nucleotides in deletions. Two nucleotide sequences were obtained from the amplicos generated by SARS-CoV-2. In order to sequence these amplicos, nanopore and Sanger sequencing technology were used. These sequences were aligned to SARS-CoV-2 genome, and these alignments supported the existence of the 211 nucleotide deletions. 1% agarose yield show 411 nucleotide deletions in SARS-CoV-2 genome samples. For samples without deletion, a size of approx 600 nucleotides was expected, while for samples with deletion, the size was 200 nucleotides. However, some samples assigned to the B.1.243 lineages did not find the 411 nucleotide deletion. InDel-Mex showed the 411 nucleotide deletion, but surprisingly, a new deletion assigned to lineage V.1.243 with a size of the 222 nucleotide was found. In the figure of the left, we can observe the coverage of the some samples and the lack of readings in ORFS 7 and 8. When the 222 nucleotide deletion was detected, it was decided to test all available samples for SARS CoV-2. InDel-Mex managed to detect 97 samples with the existence of deletion in ORFS 7b and 8. The samples are varied size and lineages. In conclusion, at least 3% of each month analyzed there was a deletion in ORFS 7a, 7b, and 8. It seems that deletions are less recurrent in ORFS 7b of SARS-CoV-2. InDel-Mex needs to be improved to accomplish the task to scan the entire genome. It's all for this presentation. Thank you for your attention.